and 9.6 to kind of just hit on the highlights of what you need and make sure you get all of the information that you need. So in this lesson, we're applying compositions of transformations. And I mentioned in class, in this book, up until this point, we have only done rotations, reflections, and translations. So we're going to combine two or more transformations that are rotations, reflections, or translations. We haven't spoken about dilations yet. So also, every combination of these is going to mean that the figure is still going to be congruent to the original figure. So once again, the new image will be congruent to the pre-image, is the way you'll see that written mathematically. So I'm going to skip through these warm-up exercises and first go through a glide reflection. And also here they're using just a line segment that's not a whole figure. So they're taking the blue line segment PQ and translating it up. You may have actually heard that word in elementary school called a glide or a slide. Then they're reflecting it over the line K, and you get the final image of P double prime, Q double prime. The thing that's important to note in a glide reflection is had I changed the order and done the reflection first and then the translation, the final image would have been in the same location. So when I am translating and reflecting or reflecting and translating, the order of that does not matter. And that's what they do here. If you want, you can stop the video. You can look at all the points. But basically they're saying XY is the translation X negative 12Y. I also said briefly in class, I'll mention it here, if I do it as vector notation, be negative 12, 0. Instead of writing out that way, that would just mean X would move 12 to the left, and Y wouldn't change at all. So when we did that transformation and then reflected it over the x-axis, this is where the figure ends up. Now, had we reflected it, let's do the reflection here, should be right there, and then slid it over, you can see then either way it would end up in the same location. Okay. So I cut through some slides here, and that's what I'm trying to do on this lesson, is kind of just give you the highlights so you don't have to watch a 30-minute video. If you want to watch the whole video, you can watch the whole video from last year. Now we're going to talk about a composition of transformations. This is a combination of multiple transformations. And as long as those transformations are all transformations that are isometries, that's translations, rotations, and reflections, then it's an isometry. Basically, isometry is just a fancy term for something that preserves congruence. So no matter what I do, translate, rotate, reflect, etc., I'm preserving congruence, no matter how many of these I do. There is often a question on the EOC that talks about which of the following are going to be an example of an isometry, and there's lots of choices, and they say check the box that applies, and let's say this box, somewhere in it has a dilation, and somewhere in the description it has a dilation, and let's say these are like a reflection over negative y equals x. I don't even know what that is, but and a rotation of 270 degrees. I really don't need to think about what that is. If it's a reflection, it's an isometry. If it's a dilation, it's not an isometry. So I'm not going to click that box. I'm not going to click that box. I mentioned that briefly in class, and as we review for the EOC, we'll go through more examples of that type of question. Now, in this next one, it's broken into 2 points here, but they talk about reflecting in the y-axis and then rotating. So reflect, and then rotate 90 degrees. So they take this line segment, RS. If you read through the problem, that's where it is. But what I want you to get is if I reflect it over the y-axis, it moves from quadrant 4 to quadrant 3. And then I rotate it 90 degrees counterclockwise around the origin, because if it doesn't say, it's always counterclockwise. That's where I end up. Now, if I were to reflect this, if I were to change the order, if I were to rotate this first 90 degrees, I'm going to end up in quadrant 1. Then when I reflect that over the y-axis, I'm going to end up in quadrant 2. So the order here does matter that you do the composition of transformations. If there is a rotation in your composition, it is going to change where the final image is based upon whether you rotate first or second. Obviously, if there's 3 different things, whether you rotate first, second, or third. Now we get into 2 types of theorems where the final image could be found 2 different ways. So we're first going to talk about reflections in parallel lines. So here I have parallel line K and parallel line M. If I take image line segment QP and I reflect it over one parallel line and I reflect it again over a second parallel line, it is the same as a translation. So where you might see this written on an EOC is, oh, that's white. That's not going to help. I need it to be like a color. It's white again. Let's put a color in here. Neil looked at line segment QP compared to the final image, which is line QP. I'm going to put double prime because I'm not going to spend the time to put those little things up. And said it was a translation. Stephanie looked at the same problem and said it was a series of reflections over 2 parallel lines. Who is correct? So once again, Neil looked at the line segment, blue one to the green one, said, oh, that's a translation. Stephanie looked at the same problem and said it was a reflection over 2 parallel lines. Who is correct? They both are. Okay. Now the other type of problem you would have is, I'm trying to get to it, if lines intersect. So here I have line M and line K intersecting. And I have segment AB, and I want to get to A double prime, B double prime. If I reflect this image over line K and over line M, then it is 2 reflections over 2 intersecting lines. It would also be a rotation. And the angle of rotation is whatever the angle is of the 2 intersecting lines times 2. So this one we'll look at a few problems. Here I tried to show an image to the kids of it rotated. But here's a blue fish. I reflected it over line K and got the image of the red fish. Then I reflected it again and got the green fish. So to get from the blue fish to the green fish, It could be a reflection over two intersecting lines, or as a single transformation, it's a rotation of 140 degrees. And I know it's 140 because the two lines intersect, they form a 70-degree angle there. So 2 times 70 is 140. Okay. Another example here, to get the blue figure to the green figure. I reflected it over K, reflected it over M, or rotated it 160 degrees. 160 degrees because that's twice 80. And that is the review of these problems. If you want, you can try these. You can pause and check your answers. You can pause, check your answer. And that took us onto our homework. When we did this homework, 7 through 10, if you wanted to, you could graph these to find the answers. If you didn't want to graph them, as long as you could come up with the vertices of where they ended at. All of these are on my website. On 11 and 12, what I really cared about was you understanding if the order of the transformations affected the final image. In number 11, a translation and then a reflection. That's a glide reflection. So whether I translate and reflect or reflect first, then translate, the final image is going to be in the same location. But for number 12, if I reflect and rotate, or first rotate, then reflect, it's going to affect the final location of the image. Hope that helps you all out very much.